Hello, everybody. My name is Sai Chakravarthy Annam. I'm a principal data engineer at Palo Alto Networks, working for marketing, data science, and operations team. Today, I'll take you through our journey to Google Cloud Platform. So, just to set context, I would show how our systems look before and after Google Cloud Platform, and then we'll dig into architecture and how the services work on our new system. So to show you how our old system looked, it had like a lot of moving pieces, and it's based on Hadoop, which involves a lot of maintenance. And when a node goes down, it takes hours to days to bring that node back and resume our loads. And we also had code promotion issues with 300 plus workflows. It's hard to maintain the code versioning and then making sure that we don't overwrite someone else's work. And we also had issues with time-based scheduling with 300 plus workflows. I said finding an available slot and deploying a new workflow in available slot is tedious work. So to overcome all these issues, we came up with a new, clean, robust, and scalable system, which would look similar to this car, which is very clean and everything is operated from a central console and easy to monitor this kind of a system. To achieve this kind of system, we need a strong architecture. And we put KNIME at the center of our architecture because we have been using KNIME for 5+ years and we love KNIME, and we have developed 300 plus workflows using KNIME. So we don't want to move this away from KNIME or build something completely new and build all these 300 workflows from scratch. That being said, with Google Cloud Platform, we have everything into a project. So everything in the Google Cloud Platform is bucketed into projects. And as a company, we decided to have Data Lake project as a center system for all our data, meaning everything that we store goes into this project. And all the other business units just use that data from Data Lake project and then process the data and put it back into that data. So data lives in one single project and centrally maintained by our infra and IT teams. So now, in the initial days of this migration, the issue that we faced is ability of KNIME to talk across multiple projects. So KNIME has their own native nodes that can talk between inside the project. If we have BigQuery or Google Cloud Storage inside this marketing project, we have KNIME nodes to do that. But in our complex architecture where the data is in a different project and the compute is in a different project, so we have to come up with a solution that solves this problem. In our case, we built microservices that basically acts as a bridge between KNIME and Google Cloud Platform, or data inside the Google Cloud Platform. So this microservices talk to KNIME, and then they makes a bridge between marketing project and Data Lake project, and then pulls data in and out of Data Lake project. And since we invented this microservices, we want to throw a lot of other features into this microservices that then can be used as a package of KNIME and microservices to communicate with other business applications like Marketo, Adobe Analytics, and Salesforce, etc. So now we saw a high-level architecture of our system. So let's see how this KNIME and microservices work together to do all this magic. So if you see this one, this is like a 3-level architecture where KNIME sits on the top, where developers develop their workflows and deploy them. And microservices are the middle layer, which acts as a bridge between data and KNIME. And the third layer is a data layer, which holds the actual data and the applications. To see how these things work together, let's go through this simple example of KNIME workflow where you pull data from a Google Cloud bucket, filter them, group by, and then write it to BigQuery table, and also push the same data into dashboard. To see how it works, when this component of KNIME is invoked, it just calls a Python framework, and then Python framework calls Google Cloud Storage and puts data back into KNIME. And then row filter, group by, and then once the data is ready after group by, we need to write it back to BigQuery. And that again invokes Python framework, which would then write data back into a BigQuery table. Similarly, push to dashboard, push data to dashboard invokes a JavaScript that pushes data into Einstein Analytics platform. And with these components being the secret sauce, I would say, which actually combines a lot of components into one single component, and then they can basically act as a service to data scientists who doesn't have to know what's happening under the hood. It just acts as a service. And with these services, microservices, we added data quality and logging features inbuilt into these services. Anything that we log into, or anything that we write or read from these systems is logged into a BigQuery table, and then that table can be used as a used for dashboarding purposes by data scientists for their operational purposes. And with the combination of GCP, KNIME, and microservices, we were able to achieve these wonderful new 4 features in the new system, which is GDPR. In our old system, we used to scan 1,600 tables to identify where the PII information is. Now with the power of GCP, which has a labeling feature, we can just label the columns saying during the time of creation to say whether the particular column has a PII information or not. And then that we use those kind of labels to identify these tables to purge them. So in this case, we reduced from 1,700 table or 1,600 table scan to 40 tables. And then that increased a lot of performance on our systems. And data quality and logging are inbuilt into our services, which means developer don't have to worry about the data quality, which is already taken care by these services. They can focus their time on developing new things. And notifications is the last one, which is also incorporated into most of our services, where you can just get a Slack notification or an email with all the information that you need. You don't even have, a developer don't even have to log into the servers to see how their workflows are running on a daily basis. They can just look at their emails and get information on their workflow statuses. With this, we were able to move from our old complicated system to a clean design system, clean design with help of GCP, KNIME, and the in-house developed microservices. Thanks for your time today. And Jim, any questions?
Yeah, I had a question about components. So it sounded like the way you use components, or maybe one of the fallouts of using components was being able to have people who like know Python or maybe know Java or some other technology, they can kind of hide that from the users of the components. Does that kind of follow the way you used it?
Yes, so that's exactly how we used it. We developed everything. As a data engineer, we develop everything in Python or Java and then just wrap it into a component. And data scientists don't have to worry about the technicalities that's happening under the hood. They can just drag and drop that service node and just run with it.
Okay, excellent. Good. Thank you so much. All right. Well, thank you. And we'll see you at KNIME Summit.